Before I get started, I want to show you guys something that you might not want to happen in your circuits. I've got a little setup here that will demonstrate what can happen if you choose an incorrect resistor. So I'm going to connect the resistor that I have here to the battery, and we will observe exactly what happens, and then we'll go on to explain why later on. So here we go. Keep your eyes on the resistor. There we go. We had a little mini fire explosion. That's obviously something you don't want to happen in your circuits, as it is a fire risk. However, if you are working in a safely controlled environment, you should be fine. We will now go into why that happened and how to make sure that you choose the right resistor for your circuit. What I used was a 15 ohm resistor. This is my strip of 15 ohm resistors. If you recall the video that I've done, if you don't, I recommend you have a look. I did a video on calculating power. The calculating power equation, if you have seen it, is P equals IV, or power is equal to the current times voltage. Resistors, all types of resistors, have a certain power rating. And these types of resistors here are rated for only 1/4 of a watt. So if I put more than 1/4 of a watt through it, they will start to get very hot, or if I'm too much over the threshold, they will get they will set on fire, as you've just seen. Now, these resistors I have on this side, these are 1 watt resistors. So these resistors physically look bigger, but they also can handle more power. They can handle more power than these smaller ones. And that's why they are significantly bigger. So if it's not obvious already, the reason why the resistor here blew up is because obviously there was too much current going through it. The equation for calculating current, we need to do that before we know how much power went through the resistor. So we need to calculate the current that was going through the resistor in order to calculate the power that was going through it. So if we do the maths, I equals V over R, so the current going through the resistor was equal to the voltage, which this battery is a 12 volt battery, and it's roughly 13 volts now, but we're going to use 12 volts just for the sake of using 12 volts. It's a 12 volt battery, and the mathematics there would be 12 volts divided by the resistance, which here the resistance is 15 ohms. So if we do 12 divided by 15, then you can see the answer here is 0.8 amps. Now that's quite a lot. That's 800 milliamps at 12 volts. And this is where we can calculate the power now. We know the current that was flowing through that resistor, and we know the voltage. And if you remember, power is equal to current times voltage, or P equals IV. So the current, which is 0.8 amps times 12 volts, gives us a total of 9.6 watts. 9.6 watts of power went through a resistor only rated for 1/4 of a watt, or 0.25 watts. Now, because that was in the extremes of exceeding the power rating of a resistor, that particular one I did set on fire because I was putting pretty much 10 watts through a 1/4 watt resistor. However, you can sometimes be using a resistor that seems to be working, but actually is getting very, very, very hot. And this can happen if you're just slightly exceeding the power rating of it. So if you're putting 0.3 watts through a resistor that's rated 0.25, then the resistor is going to get very, very, very hot. And you're probably going to shorten its lifespan. And depending on what you're using the resistor in, it may end up overheating itself or other components in the circuit. It could end up even melting plastic. So you must ensure that the power that's being put through the resistor is way under the threshold of what it's designed for, just to make sure it's safe and just to make sure it runs at a decent enough temperature, not too hot, and not overheating and shortening its lifespan.